Okay, so today we talked about different ways we could solve for mass or volume if we're given density. And we're going to learn how to solve these problems using ratios. So when I do a ratio, this side is always going to have my density. So for every 1 milliliter, there are 0.6 grams of that metal. If I was going to write a statement that talked about the relationship, I would say that grams are 0.6 times smaller than milliliters. And you could write the relationship over here many different ways. That's just one way. So if I want you to write a relationship for the density, that's what I mean. The grams are 0.6 times smaller than the milliliters. So over here, our mass is going to go on the top. Grams go on the top. And on the bottom, we're going to have milliliters. And I'm going to put a question mark. Now, sometimes we want the same relationship. We want this to be 6.6 times smaller than this. That tells us that the way you can double check using ratios, which is why I like that, is that should this number be bigger or smaller than 13? Well, this number is bigger than 0.6, so this has got to be bigger than 13. And it's got to be 0.6 times bigger. And if you don't really know how to do that kind of math, it's going to be 0.6 times bigger. You could do both ways. What if I multiply by 0.6, and what if I divide by 0.6? If I multiply by 0.6, my answer is 7.8. If I divide by 6, my answer is 21.6666, and it keeps going, 7. Well, if I know that my answer needs to be bigger, I'm going to pick this one, 21.666667. And actually, another way to check this, 1.6667, a way to double check, if you will, is to actually do the division on both sides. 0.6 divided by 1 is 0.6. In my calculator, if I do 13 divided by 21.6, 13 divided by 21.66667, I get, well, if we rounded that, pretty close to 0.6. That's my double check. 0.6 equals 0.6. This relationship is the same as this. I'm all set. And the last thing we need to consider is rounding, and this is a little difficult. This has 1 digit, it's 1 sig fig. This has 2. So we need to get this to somehow be like our worst measurement, because we need to be modest as a scientist. So, this is less accurate than this, because this is 1 sig fig. And this one is 2 sig figs. So I want my answer to look like 1 sig fig. So how do I round this to look at 1 sig fig? Well, when we did this as a class, 21.66667, we said, okay, well, how can I make this less accurate? Oops. Sorry about that. Yeah, this is, okay. Sorry about that. Someone came to my door. Okay, so if I wanted to make this less accurate, someone said, well, you could round this to 21.7. But this is 3 sig figs, and this is only 1. This is still more accurate than this number is. So someone else suggested rounding it to 22. Well, but that's still more accurate than that number. Somebody said, well, to make it even less accurate, we could do 20. It looks like it's 2 sig figs, but we got to talk about our placeholder zeros. Zeros are not always significant. There's 2 different kinds of 20s, 20 with a decimal and 20 without. This decimal does not mean that we know it to the tens place. What this decimal means is that this first number is, this 0 is significant. And what I mean by that is our measurement could be 20, or it could be 21, or 22. This is saying that this is my estimation number. If there is no decimal, it's telling me that this first number is my estimation number. Instead of 20, it could be 30 or it could be 40. It's skipping this and saying, well, this is really my measurement number, and that's the one we're unsure of. This is just holding the place of the one we're unsure of. So here's my rules so you can identify a placeholder or zero. Number zeros at the end of the number are placeholders if it's inaccurate and there is no decimal. So in this case, this would be 1 sig fig.